Okay, this next lesson is a good one. This next lesson is something that will hopefully help you with word problems. I've noticed in class especially, word problems are always challenging for students. There's a lot you have to juggle. You have to keep on top of what they're asking, what they're telling you. You have to remember things you've learned before and how to apply them. I enjoy the puzzle aspect of it. I like the feeling you get when you solve one, but I know not everybody agrees with me on that. So, for today's lesson, Module 2, Lesson 3, let's talk about how we break these apart. Put my Roman numeral in there. Let's talk about how we read, and actually let me say reading and writing numerical expressions. Now, some of you probably asking, what does that have to do with anything? What does that even mean? What are numerical expressions? Ooh, I'm so glad you asked. Let's talk about that. Let's start with our vocabulary for today. I just wonder why it glares up like that. Because my hand is too bright? I don't know. All right, vocabulary. First, let's talk about what an expression is. Okay? Hopefully you've heard me say this in class. Hopefully you've heard it from other math teachers as well. An expression is just numbers, operators. Well, that sounds like that would be a good vocabulary word too, doesn't it? Numbers, operators, and or symbols. We do love our symbols in math. Numbers, operators, and or symbols grouped together to show a value. When you see an expression, it's going to be numbers, operators, symbols, whatever. These things are grouped together to show you some value. Now, it doesn't just say the value is 18. It's going to give you 2 times 9. And those things taken together will have the value of 18. We'll do more examples in a minute. I'll give you some visuals. But let's finish our vocabulary first. We've got 2 more words I want to discuss. First one, again from above, operators. Okay. This is a fancy math term for things that you have been using for years and years and years and years. This is your plus sign. This is your minus sign. Multiplication sign. Your division sign. There are a couple other things we'll look at in a minute. But operators are just telling you that you are going to do an operation. You are going to add, you are going to subtract, you are going to multiply, you are going to divide. Okay? Now, one of the ways this gets tricky is when we get down to the order of operations. I always like sharing this with 5th graders because I don't remember learning about it until I was in middle school or high school. So I'm giving it to you a little bit early. Hopefully it will serve you well. Maybe you've heard of it already. You may have heard it in 4th grade or even 3rd grade. The order of operations is Pemdas. Yeah, okay, so what does that mean? Pemdas means that anytime you have an expression, or later we'll talk about equations, if you see parentheses, you are going to take care of whatever's in the parentheses first. You're going to do whatever's in the parentheses first. Next, you're going to look and see if there are any exponents. If you see any exponents, do them next. Now, sometimes the exponents will show up in the problem before the parentheses. Doesn't matter. Doesn't matter. always do the parentheses first. Parentheses, exponents. The next two go together, and you could probably guess what they are. Multiply and divide. I'll show you some examples. Multiply and divide go together because they're kind of the same thing. That's a tricky thing to wrap your head around probably, but they're very closely related, which means we're going to do them together as part of the same step. Last one, you should definitely be able to guess based on that. Add and subtract. Going out to the margins a little bit there. Okay. So the order of operations: parentheses, exponents, multiply, divide, add, subtract. Please don't feel like you have to completely understand what that means right now. We are going to do some examples together. I'm going to zoom back over here. Okay. Now I know this has been a little irregular. I really like to have B be the process. I want to try to be consistent. I kind of have two processes we're going to do today. So the first one is when you're going from word form. You're going from word form to numerical expression. This is when you are reading a word problem and you are trying to turn it into something you can solve. You're trying to turn it into something you can work with. So for example, if I give you 3 times the sum of 24 and 4. I'm going to read it again because I like doing that voice. 3 times the sum of 24 and 4. Okay, we need to try to turn this into an expression. We need to turn this into something I can find the value of. It helps to look for clue phrases. Now, there's no way I can list every single clue phrase in this particular note video, but hopefully a lot of you latched on to this phrase right here, the sum of. This clue phrase has a very specific meaning. This clue phrase is always going to translate the sum of. Well, that means we're adding 2 things. The sum of. And I shouldn't say 2. It's 2 in this case. It could be more. If I say the sum of 24, 4, and 11, then I'm adding 3 things. It just means you're adding whatever comes next. Now I'm going to do one other thing. I'm going to put parentheses around it. I love parentheses because parentheses, if you can think about everything inside of them, parentheses are like a box or a bag. Everything inside of them goes together. Everything inside of them has one value. It's almost like you can think of, even though it's broken apart into pieces, this is one number. It's the same way when you get a puzzle. If you buy a puzzle, it comes in a box, it's all busted up, all the pieces are separated, but you know it's going to go together to create one image, one solid thing. That's kind of what parentheses are. Okay. So going back 3 times, that most of you probably, I'm going to throw this pencil, most of you probably wanted to do that already 3 times. Okay. We're multiplying 3 times something. The something is going to be the sum of 24 and 4. The sum of 24 and 4. Now, I'm not going to solve this right now because honestly, that's not the main part of the lesson. Translating from words to expression, that's your focus. Eventually, we will solve. 24 plus 4, you do the parentheses first. 24 plus 4, that's 28. Multiply 28 times 3, that would be 60 plus 24 is about 84. Okay? But again, not even going to write that down because right now, I don't care. I get to use that silly voice again. 6 times the difference between 6 times the difference between 60 and 51. Kind of went into like movie trailer voice for that one. I don't know. All right, 6 times the difference between 60 and 51. We're looking for a clue phrase again. I'm guessing a lot of you are watching the screen going, it's this one, it's this. It is this one. The difference between. Okay, the difference between. Sum was addition, while difference, I think most of you recognize, means subtraction. So this clue phrase, I'm going to use my parentheses again because I like my puzzle box. This time the operator is going to be subtraction. And then, yeah, I'm just finding the difference between two numbers. I'm going to subtract these two numbers. So, 6 times the difference between 60 and 51. This is one of the few times, if you see it set up this way with the difference between, where you just automatically are going to put the larger one first. Okay, so that's kind of nice. If I were solving this, I would do the parentheses first. 60 minus 51 is 9. 9 times 6 is 54. Okay. All right, number 3. The sum, oh, I didn't do my voice. The sum of 2 12s and 4 3s. Okay, oh, close quotations. Oh boy, okay, well, we have our clue sentence again. The sum of, so I'm going to cut that stuff out. We've done that already. The sum of, I know we're going to be adding, right? But it says the sum of 2 12s. 2 12s. Now, a lot of you have already done that in your head. You're like, it's 24. Yeah. But I still want to try to represent it in my expression. 2 12s. Now, I could write 12 plus 12. But looking at 4 3s, I don't really want to put 3 plus 3 plus 3 plus 3. If this had been 12 12s, or you're going to want to write 12 plus 12 plus 12 plus 12, blah, 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 blah. If it says we have 2 of something, then I'm going to multiply 2 times the something. If it says I have 4 of something, I am going to multiply 4 times the something. Now, these are just 3 quick examples. We will do more in class. This is where you will most often be using this skill. You're going to take something in a word problem, something in a phrase, and you are going to try to turn it into an expression you can solve, that you can evaluate. Now, you can go the other way also. I'll do 2 quick examples here, but we are starting to run a bit long. If you're going from numerical expression to word form, ultimately what this is saying is, how do you read these things? Okay. So if I give you blah, 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 a lot of you would probably read this as 8 times 43 minus 13. And while that's not technically incorrect, it can confuse things. This is where students think that they'll get the right answer by using a calculator, but because they're ignoring the parentheses, they'll end up getting something that's wrong. Reading this is important because it helps indicate what we should do first. 8 times, that part's okay. I want to go in the order it's in. 8 times. Now, we are going to use our clue phrase. We're subtracting, so 8 times the difference, pencil, the difference between. 8 times the difference between 43 and 13. Let me slide that over so it's showing up. 8 times the difference between 43 and 13. Let's do another one. Okay. If I give you this, and I give you this, this probably looks a bit more like the item here. When I see the parentheses, I can say the product of 20 times 3 added to the product of 5 times 3. That works, but it's a little long and it doesn't really sound very natural. Even though, I know, we're not strictly going in order, if you look at this and say, well, I know I'm adding 2 things, okay? The sum of 23s and 5 3s. The sum of something and something. That can be a little smoother. Now we're going to go ahead and stop here. As always, you can plan on more examples during class. If you have any questions, make sure you bring them. The big things to remember. For once, I would say probably the big focus here is the vocabulary, because we're going to be using these things a lot. I am going to be using them quite a bit while we're going through. So please pay close attention. Again, I know this one's running long, so I'm going to wrap up. We'll discuss more in class. Thank you, folks. You are done for now.